Hi, welcome to the HESI Prep course in Mathematics Part 2. I am Professor Candy Mowen, or Promo for short, and I will take you through the second part here. We're going to look at continuing to help you prepare for the HES course. We're going to look at some basic concepts, tables, charts, and graphs. We're going to look at how they're interpreted and how relevant information they are, evaluating that information, the relationship between the variables. We're going to look at geometry and a couple geometric figures, triangles, quadrilaterals, and circles, and conversion, using conversion fractions. So first we're going to look at tables, charts, and graphs. We're going to look at some of the relationships with using all those. We're going to look at uh, derivative data, types of tables, charts, and graphs, the mean value, the mean rate of change, interpolation and extrapolation, independent and dependent variables. So when you're looking at derivative data, we have two variables. They may or may not be related. Some examples of that is height and weight of the students, temperature and the amount of ice cream sold for each day. You can tell how that may not be related. Hours of study and grade on the exam, shoe size, and the number of siblings. So here we have a list and list of data values. For example, Ryan's grades on 10 quizzes listed. What we do here is a table presents data that is gathered. If we're looking for a sample and we're looking for, if you're in a business and you want to look at sales of a certain product you have, you're going to collect data. And the best way, I'm a little bit OCD, is I like to present it in a table. Helps you, especially when you are trying to put a graph together. It help tell a picture of the graph or of the data that you have collected. For example, here we have the population of the largest countries. We rank them 1 through 6. We have the name of the country and the 2018 or 2018 population. It's gathered, it shows us, it's very neat. The line graph is an example. It has two numeric perimeters. It's independent on the horizontal axis, dependent on the vertical axis. The number of days of rain. Graphs have a title. They have an x-axis or horizontal and a vertical axis. Here we have the number of months labeled on our horizontal and the days of rain on our vertical. I can tell you I'm not a fan of a line graph. It's really hard to read sometimes unless you have different points set. Sometimes graphs are good to have notes to tell, especially if you're giving them, as I said, as a business, maybe you're looking at shareholders. You want somebody that isn't a person that is a customary with statistics. They need to have notes. They need to have explanations. Scatter plot. Two parameters may or may not be related, as the examples we talked about previously. You can show whether the data is correlated. It cannot show cause and effect, and it just shows you how it is scattered, close to what we're looking at. And we're going to talk about the mean here in a minute. Pay attention to the title. Legend or key for shapes, colors, or etc. As we say about in cooking, presentation is everything. Axis, have a scale. Labels, units, and notes and captions when you're coming together with graphs, tables, and charts. Interpreting relevant information. The mean value, the mean rate of change. Mean is the average. It's the arithmetic average. It can be symbols there meaning X bar is mean or mu. It's when you have all the items that of your data, you add them together and divide by the number of pieces of data. For this following, find the mean of the following numbers: 1, 3, 4, 4, 6, 8, 9. The mean, add them all together. There's 7 pieces of data. 42 is the sum, divided by the pieces of data is 7. X, or mean, is 6. The mean rate of change, it's for a derivative data. Change in y is y sub 2 minus y sub 1. over the change in x. X sub 2 minus x sub 1. This is equal to the slope of a line. Definitions, interpolation, estimating data points between known data points. Extrapolation is estimating data points beyond the known data points. Now, interpolation, the height of a plant has measured on days 1, 2, 5, and 7, and is shown on the following graph. What would you estimate the plant height was on day 4? So there again, you want to make sure you can have your label, you have your axis labeled height in millimeters and the day. So it was measured. What would the estimate of the plant height on day 4? So you go out here to 4 and you go up, okay, and it's right there. Look across where they intersect. It's 20 millimeters. Now, exploration, what would the estimate of the plant height would be on day 10? So you have to kind of extend it out here because the original only showed it to day 7. So we're going to have a dotted line extending out here to day 10. What is the height on day 10? We go up 50 millimeters. It's outside the original collection or presentation. Which is which, independent or dependent? If we let X be independent and Y be dependent, that can be our cause, that can be our effect, does not depend on Y, depends on X. For example, ice cream sales and daily high temperatures. The temperature affects the ice cream sales, not the other way around. Temperature is equal to independent variable. Sales equals dependent variable. Okay, evaluating information. We're going to look at measures of central tendency and dispersion, distribution, symmetry, skewness, and modality. Trends, expected and unexpected values, and real-world contexts. Concept, a measure of the center of the data. Call them the 3 M's, mean, median, and mode. The mean is what we just talked about. Find the average of the data set. Find the mean of the following data. You add up the sum. It's 50. How many pieces of data? 5. 5 divided into 50 equals 10 is your X bar. The median is just what it sounds like, folks. The middle of the set of data. There are two things that you have to consider when you're finding the mean. Put the numbers in ascending order. Find the middle number. Here we have 1, 2, 3, 4, 5 pieces. This means that they're the pieces of data. There are 5. That is odd. Put the number in order. 2, 3, 5, 6, 8. Just look at the middle. The median is 5. Okay. Here again, it's just median is the value that is ranked data. When we say ranked, place them in ascending or descending order. We have numeric values here. We have 5 pieces of data. Look at right in the middle. That's the median, $327. Now, we've looked at it with odd pieces of data. You're not always going to have odd pieces. Sometimes you may have even pieces of data. Determine the median of the following set. Rank your set, smallest to largest. We have 10 pieces of data, which lie halfway between the middle pieces. So you rank your data, you take your 2 middle pieces, in this case 7 and 8. You add your 2 middle pieces together, divide by 2, and that's the median if you're dealing with even pieces of data. 7 plus 8, 15 divided by 2, median 7.5. Okay, the mode, the data point that occurs the most frequent. Here we're looking at a data set. Since the mode is 3, it occurs or appears 3 times. That's more than any other number. Sometimes you may have pieces of data that do not only appear once. There is no mode then. Sometimes it might be bimodal. Let's say we added another 8. In this case, you'd have 2 modes, 3 and 8. Dispersion. a measure of how dispersed or spread out the data is. This is the range. This is the measures of dispersion. You take the largest data value minus the smallest data value in the piece, a set of data. Here, find the range. Here, the largest is 98, the smallest is 26. We subtract, the range is 72 in this group of data. That's finding your range. How do we show distributions? The normal distribution is the bell-shaped curve, and right here down the middle, this illustrates, you want to find it maybe closest to the mean, median, or mode, the 3 M's. The mean is the most used way of finding and looking at different ways of statistics. Uniform distribution, it's consistent. Okay, we can see how it is A and B, and it is uniform. Symmetry. Symmetry is how we distribute. We have right and left sides of distribution. There are mirror images of each other. Here we have the bell-shaped curve. Here we have and see that there are mirrors of each other. Sometimes we skew our data. Sometimes it's intentional to paint a different picture than what actually has occurred when we collect our data. If the result is skewed to the left, this is how we picture it. If it's normal, we have our bell-shaped curve. If it is skewed to the right, this is how we display it. Modality is unimodal, bimodal, neither. Unimodal has a single mode, one clear peak. Might be skewed, but it still has one clear peak. Bimodal has two modes, two clear peaks, and neither has no modes or more modes or no modes. Now, trends. Look for a trend in the data. Some of the examples are always increasing or decreasing. Increases more slowly as time goes, or increases more quickly as time goes. Stays about the same. Decreases while then increases, or increases while then decreases. These are trends that you look at when you're looking at data. Evaluating information in a real-world context. Explain a point on a graph. What is the meaning of the red point on the graph? Again, we have their days of rain. This means there was 12 days of rain in June. There again, with graphs, we are trying to paint a picture or tell a story of the data that we have collected. Unexpected values, or we call them outliers. They're far from other data points, not where expected. It can include or ignore depending on how the data is used, if it's going to tell you something that you really need to know. Here, you can see pretty much everything is kind of going together. These are a little bit out there, but they still follow the same line. Out here is something way out of line, and this is our outliner, okay? Right here. Relationships between variables. Are they independent or dependent? Correlation. Or linear or non-linear relationships. On a graph, independent variables generally on the horizontal axis. Dependent variables are generally on the vertical axis. Correlation. It's related to each other. Positive correlation, both increase or decrease together. Negative correlation, one increases while the other decreases. No correlation, no relation between the two. Correlation is when they gather. They gather together. They're related to each other. Linear relationship. Parameters are related. Scatter plot follows a line. Non-linear relationships. Parameters are related. Scatter plot does not close follow a line. There's kind of scattered. Here you can see kind of a line. Here they're scattered. They look almost like a parabola. We're not going to take a break. We're going to continue here. We don't have that much to go, so we're just going to continue. We're going to talk now about geometry. Some of the geometric figures, triangles, quadrilaterals, and circles. We have a perimeter and circumference, area, including irregular shapes, volume and surface area of solids, and arc and central angle. Perimeter, the perimeter of a polygon, its distance around the edge. You add the lengths of one side. For a square, the formula is P equals 4S, where S is the length of each side. A rectangle, the perimeter is P equals 2L plus 2W, which is perimeter equals length and width. So 2 times the length plus 2 times the width. There again, formulas. They're like what we talked about in part 1 with algebra. If you know, uh, in the case of a rectangle, if you know the length and the width, you can always find the perimeter. If you know the perimeter and the width, you can always find the length. So that's what we do, and we're substituting. There again, we're looking for our unknowns. Perimeter problem. Graham wants to put a fence around his garden. Use the diagram below to figure out how many feet of fencing he will need. There again, you must find the missing lengths. To find the perimeter, there again, we see that we have some missing lengths here in red. We have 7 plus 7 plus 14 plus 4 plus 7 plus 3. It is 42 feet. And there's sometimes, folks, you may have to do a dotted line and then find out what is left. The circumference is of a circle, the distance around the edge. C equals 2 pi r. C is the circumference, r is the radius. Pi is 3.14. They may ask you to use that decimal equivalent. If not, and you're allowed to use a calculator, then they might ask you to use the pi function key on your calculator. Now, again, when we talk about circles, there's a dissection of a circle, and I think we are going to dissect here. Like if we're cutting a pie or a circle, that's the diameter, D. The radius is half the diameter, and C is the circumference around. So Yasmin likes to walk in a circular park near her house. There's a path around the edge of the park and another path straight through the center, as shown below. The radius of the circle is 500 feet. How long is the path through the center of the park? How long is the path across the park? So the radius of the circle is 500 feet. Okay, across the center. Diameter is 2 times the radius. You know, you cut the radius, the radius is half the diameter. So 2 times 500, 3,000 feet. Around the edge, it's 2 pi r. 2 times, we're using the 3.14 times 500 equals 3,140 feet. Area of a triangle, the amount of space the triangle covers. A equals 1/2 BH. A is the area, B is equal to the base, and H is equal to the height. Play and Learn Preschool is putting in a new triangular play yard, as indicated in the diagram below. What will the area of the play yard be? For the triangle, A equals 1/2 B times H. Okay, we have 1/2, 20 feet is the base, 20 feet is the height. Multiply 20 times 20 is 400. Half of that is 200. If we're finding the area, remember the units of the final answer is always square units. So then the area of the play yard will be 200 square feet. Areas of quadrilaterals, the amount of space the quadrilateral covers. Square is A equals S to the second power, or side squared. A is your area, S is the length of each side. Rectangle, A is area times length times width. Rick wants to plant a rectangular garden with the area of 35 square feet. He wants the garden to be 7 feet long. How wide would he make the garden? Okay, we're going to plug it in. Like I said, if you know 2 of the 3 of the formula, you can always find the unknown. In this case, our unknown is W, the width. 35 equals 7 feet, or 7L times W. We are going to divide both sides by 7, and we get 5 feet equals the W, or the width is 5 feet. Area of a circle, the amount of space the circle covers. A equals pi r squared. Area equals radius squared times r pi. Approximately, what is the area of a 12-inch pizza? We're going to use 3.144 pi. A 12-inch pizza has a diameter of 12 inches. For the circle, A equals pi r squared. Radius is half the diameter, so it is 6 inches. 3.14 times 6 inches squared. You're going to square 6. 6 times 6 is 36 times 3.14. Area is approximately 113 square inches because we are dealing with area. Irregular shapes break into shapes that you can find area of. Added, area of the blue shape equals area of the green, which is a rectangle, plus yellow is a rectangle. There again, you are, putting and adding things together, and plus the area of the red rectangle. You subtract the area of the blue shapes, the area of the shape minus the area of the square. Okay, you find the area of the circle, the area of the square, and then you subtract. Okay, find the area of the shape below with the given lengths. Okay, then we're going to square it off, cut it into rectangles, find the length of each side, calculate area equals 6 times 1 plus 5 times 2 plus 6 times 3 equals 34. All right, now volume. Volume is considering three-dimensional figures. This is where, when you're finding the volume, as with area, all the units were square. With volume, all the answer unit measurements are in cubic or raised to the third power. Using the formula below, find the volume of a cylinder that has the height of 3 inches and a diameter of 4 inches. Use 3.14 for pi. The formula for a cylinder is V equals pi r squared h. Since D is 4 inches and R is 2 inches, we plug that in. Pi is 3.14 times 2 inches squared times the height 3. And then volume is approximately 37.68 inches cubed or cubic inches. Surface area. Using the formula below, find the surface area of a sphere that has a radius of 5 centimeters. Use 3.14 for pi. Surface area equals 4 pi r squared. 4 times 3.14 times 5 cubic meters squared. Surface area, 314 cubic meters. Now, we are looking at here of examples of measurements, units for length, area, and volume. Length is a length of a side or a perimeter or circumference. Its units are feet, inches, centimeters, or meters. Area, examples are area, surface area, units squared, square feet, square inches, square centimeters squared, meters squared. Volume, it's basically units are cubed, cubic feet, cubic inches. Note, if you're going for nursing, cubic centimeters is cc's. We use that in measurements for medicine. Arc of a circle, a portion of the circumference. Arc length, the length of the arc, right here. Central angle of a circle, angle with the vertex at the center of the circle as illustrated. In a circle with a circumference of 25 centimeters, a central angle of 36 degrees forms an arc with what arc length? Use a proportion. So there again, you're going to be using measurements to circumference. We're going to be using degrees to length. Angle of the measurements is 36 degrees. Remember, a whole circle is 360 degrees. Equals the arc length. We do not know it. Circumference is 25 centimeters. We cross multiply and we get 2.5 centimeters equals the arc length. Now, in a circle with a circumference of 9 inches, what is the measure of the central arc that forms an arc with an arc length of 3 inches? Again, we're going to solve it as a proportion. Angle measurement, we do not know, all over 360 degrees. The length we know is 3 inches over 9 inches. Cross multiply, and we get the angle measurement of 120 degrees. Now we're going to look at conversions, mathematical measurement and data. Conversions using fractions, metric, and U.S. customary units, set up and solve conversions and real-world problems. Common units, and we're going to look and use and compare metric to U.S. customary. The type of length is meters for metric, inches, feet, yards, and mile for U.S. customary. Mass and weight is grams and metric, ounce, pounds, and tons for U.S. customary. Volume, metric is liters. U.S. customary is teaspoons, tablespoon, fluid ounces, cups, pints, quarts, and gallons. How to set up and solve conversion problems. You convert 32 quarts to gallons. Start up with a conversion fact. 1 gallon equals 4 quarts. Conversion fact to conversion fraction. Conversion fact, 1 gallon equals 4 quarts. Create a conversion fraction. Okay, 1 gallon on top, 4 quarts on the bottom, or 4 quarts on the top, 1 gallon. Always, when we're looking at converting, you want the numerator equal the denominator, so the fraction is 1. So which one should you use and how? The original unit you're converting from, desired units will remain. If one is in the numerator, divide. If one is in the denominator, then you multiply. Okay, so you always want to find one somewhere, either in the numerator or denominator. Start with the original amount as a fraction, 32 quarts over 1. Set up the conversion fraction so that the units divide out. So you want the quarts to go out, cancel out, and go to gallons. Conversion fraction is 1, so multiply by changing the form, but not the value of the original fraction. Quarts cancel. 32 times 1 is 32. 4 quarts is 4. Divide 4 into 32, so the equivalent is 8 gallons. Benefit of this method, don't need to decide whether or not to multiply or divide. Sometimes you do have to. Now, a longer example. How many ounces is equivalent to 10 cc's? Okay, use the conversion facts. 1 cc equals 1 milliliter. 1 liter is approximately 1.06 quarts. 1 quart equals 4 cups. 1 quart cup equals 8 ounces. So how many ounces is equal to 10 cc's? Okay, so we can set this up. 100 cc's is approximately 100 cc's over 1 times 1 milliliter over 1 cc's times 1 liter over 1,000 milliliters, 1.06 quarts over 1. The quarts cancel. We want it down to 100 cc's equals approximately, we're looking for ounces, 3.392 ounces. Everything else canceled out. Folks, this is your end of your lesson for part 2. I wish you luck in preparing to set for the exam. I am the contact for this, so you will have my contact information. Email me if you have any questions. Good luck, and I wish you the best.